On what interval is the curve y equals 2e to the x minus e to the negative 3x concave downward? We may recall that concave downward means that y double prime is negative. And the picture of concave downward, it's kind of like an arch. It's a rainbow shape, right? Upside down cup. Knowing that we need the second derivative to be negative, we should, differentiate twice, right? Now, why is this in a section on logarithms? This is an exponential function. Stay tuned, let's see if it makes sense. I'd like for you to pause the video and go ahead and find y prime and y double prime. I hope that was a quick one. The derivative of 2e to the x is 2e to the x. For negative e to the negative 3x, we have to use a chain rule, so we end up with a total of y prime is equal to 2e to the x plus 3e to the negative 3x. Using the chain rule again for the second term, we get y double prime is 2e to the x minus 9e to the negative 3x. Well, we're going to have this exponential inequality. And so what I want to do first, before we find out where y double prime is negative, I want to know where y double prime equals 0. And folks, for that, I don't recommend that you write down equals 0 at the end of the expression where you wrote down y double prime, because then you're telling me y double prime is equal to 0. That may not always be true. We want to set up an equation whereby we can solve for values that make that true. Here we're going to have 2e to the x minus 9e to the negative 3x is equal to 0. I find the easiest way to deal with a situation like this is to factor out the greatest common factor. And if you remember from algebra, that would be when you have the same base, we're going to factor out the smallest exponent. So I'm going to factor out e to the negative 3x, and what I'm going to be left with is 2e to the 4x minus 9 is equal to 0. Remember that here, if we factored out the negative 3x, that essentially for the exponent becomes x minus a negative 3x, and so that's where the 4x is coming from. You can also convince yourself this is true by distributing e to the negative 3x times 2e to the 4x will certainly give us 2e to the x. Now the range of an exponential function is positive, and in this case we would have exponential decay for y equals e to the negative 3x. The point here is that e to the negative 3x will not make this expression equal to 0. So the 0 must reside in the parentheses. In other words, 2e to the 4x minus 9 equals 0. Solving this for x, we're going to say e to the 4x is equal to 9 over 2. And now we have a variable inside the exponent, and that's where the logs are going to come in. Folks, if this feels a little fast, it's because I'm going fast, because at this point we're doing old school stuff. Applying the log to both sides, and it's going to be the natural log of e to the 4x is equal to the natural log of 9 halves. I'm using the natural log because our base was e. And because those bases match for the log and the exponential, we end up with 4x is equal to the natural log of 9 halves, which means that x is equal to 1/4 times the natural log of 9 halves. That's the value that makes the second derivative equal to 0. We wanted to know where the second derivative was less than 0. So I'm going to use the test point method. On a number line here, I'm going to mark 1/4 times the natural log of 9 halves. And I'd like to know the nature of y double prime to the left and to the right of that value. For that, it's useful to note that a calculator value for 1/4 times the natural log of 9 halves is approximately 3/10. If we pick a value to the right, say 1, and substitute that into x in the expression that gives us y double prime, and I go for the factored version, then we can see that e to the negative 3 is a positive factor. 2 times e to the 4th is a very positive number. Minus 9 is going to be positive. And so to the right of this value, Our second derivative is positive, and so our graph is concave up. To the left of this value, 1/4 times the natural log of 9/2, I'm going to pick a test point of 0. That brings e to the negative 3x to be a 1. And then here we have 2 times 1 minus 9. That's a negative result. And so to the left of our point of interest, we have a negative second derivative, and so the graph is concave down. So the graph of y is concave downward on the interval from negative infinity to 1/4 times the natural log of 9/2. Now, how did I know we could go all the way to negative infinity? Like, what's going on there? Remember that our original function here was an exponential function, y equals 2e to the x minus e to the negative 3x. The domain of an exponential function is all real numbers, so I needed to take into account the entire number line when we were doing our analysis, and so that defines, or that helps me to know what interval to write down.